Welcome to January 13th LeetCode Challenge. Minimum number of arrows to burst balloons. There are some spherical balloons taped to a flat wall that represents an XY plane. The balloons are represented as a 2D integer array points where points at the index I is represented by an array where you have the first element being x to the sub start and x sub n. So these are the x coordinates where the balloon size starts and ends, which denotes a balloon whose horizontal diameter stretches between x sub start and x sub n. You don't know the exact y coordinates of the balloon. The arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. The balloon with x sub start and x sub n is burst by the arrow shot if x if x is greater than or equal to x sub start or less than or equal to x sub n. So there's no limit to the number of arrows that can be shot. A shot arrow keeps traveling infinitely and bursting any balloon in its path, given the array points, which are the minimum number of arrows that must be shot to burst all the balloons. Okay, that's a long-winded explanation, but let me kind of draw out this diagram. So you say you have a balloon here, right? This is a horrible representation of a balloon. Let's try to model this example. All right, you say you have a wall. This is starting location 0. Let's just go with that. All right, starting location index. Say this is start, x sub start, where x sub start here equals to 0. And you have the first balloon here, and x sub start and x sub n ends as 10 and 16 respectively. So say this is location 16 at this 10 at this location 10, and this is 16. Let's go with that. So the second balloon starts at index 2, so we have 2 spaces. So we have location 2, and it takes up all the way to location 8. Let me count this out. 1, 2, 3, 4, 5, 6, 7, 8. Alright. I'm just gonna go back a little bit to this. Okay, pretend this is 8, 9, 10. There you go. 1, 2, 3, 4, 5, 6. Alright. And that's how the balloons kind of look. And then location 1, 1, 2, 3, 4, 5, 6. No, wait. 2, 3, 4, 5, 6, 7, 8. 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6. Alright. Okay, and then you have balloon at 7 and 12. Let's see, this is 6, 7, 1, 8, 9, 10, 11, 12. Alright, let's see what's going on. So you have 1 to 6, there you go, 7, alright, yeah, that works. 7 and 12. Alright, and this is kind of the balloon's diameter, and how you have a little air, so you have a little person down right here shooting arrows, right? Let's say this is an arrow, boom. And this should be a little bit more. Shoots an arrow, right? So this is kind of the example here. You shoot an arrow all the way up. So the example, the minimum number of arrows you need to shoot is 2 arrows. So 1 at location x equals 6, which is actually right over here, which destroys this balloon, which is the balloon 6, 1, and destroys balloon 2, 8. and another arrow shot at location 11, which is right here, which destroys balloon 712 and 1016. That's kind of the visualization of that. It's kind of cool. Alright, so with this in mind, let's think of an approach that we could do to kind of help answer our question. So when I first thought of this, I'm thinking of the greedy solution, the greedy algorithm, right? So ideally, given an array called points, first thing you want to do is sort it out, right? It's kind of obvious to do, sort out the array. So let's do that. Let's do the sorting. I'm going to do points dot sort. Alright, now we have to sort that out. Actually, let me try to, I'm going to leave that diagram there just in case I need to go back to it. Got points dot sort. And next thing you want to do is find the most furthest right number there could be. So we want to find some x value over here called pointer n, right? Where we want we know we're going to start from 0, but we want to find the most infinite number that's farthest away. Actually, that's a float value, I should say. So we're going to call this an n pointer, and we're going to do a little trick here called negative float, and we're going to pass through infinity. Alright, and just kind of a little Python trick notation. If you want to, assign a value to a large negative number, you just use float negative. Alright, the next thing you want to do is, have a output that you can increment. So this output here is the minimum number of arrows that must be shot to burst all the balloons. Alright, so next thing you want to do is iterate through all the balloons and then count the number of arrows. Okay, you want to go through each balloon and then count the number of arrows we need to shoot all of them. So I'm gonna write out the for loop first. So for each point and points that's sorted already, there's kind of 3 conditions you want to keep in mind. So the first condition is being that let's see, you have case 1 where you have, for this example right here, right, where each balloon is actually, let's go for this example number 3 first. So we see balloon 1, the first balloon and the second balloon are overlapping by number 2, index 2, right? But this balloon is also overlapping by this balloon by index 3. And this balloon is overlapping with this balloon by index 4. So ideally, if you pop these first 2 balloons first, right, using an arrow at index 2, you have to remove them from the list, and therefore you're only left with 3 and 4. No, these 2 last balloons. Then you burst those 2 balloons. And alternatively, you can use 1 balloon to blow this up, and 1 arrow to blow this balloon, and another second arrow to blow these 2 balloons, and a third arrow, but that wouldn't be the most minimum. Well, that wouldn't be the minimum number of arrows. Otherwise, if you have balloons that don't overlap with each other, then you need 1 arrow for each balloon. That's ideally it. So every time you burst a balloon, you want to maximize or use a greedy algorithm to use 1 arrow for the most amount of balloons you can. So in order to do that, that's kind of roughly in a nutshell all the 3 cases. So you want to find if, for instance, the start value, so points at index 0, so this is x sub start, is less than or equal to the n value, right, which is the most negative number. If that's the case, then we want to find out another example. We want to find so this is the start value, x sub start. If that's the case, then we also want to find beginning. Then we need to find the end. So where does the balloon end? Where does the endings of the balloon? So we want to find if x point sub 1, if that's less than the end. So if these 2 conditions are met, that means that we have a balloon that starts and a balloon that ends within a specific parameter of each other. So therefore, we want to update our end pointer to the point at the beginning, or I mean not the point, but the ending parameter of balloon. Right? So x sub n, we want to update that to the end pointer. Else, if the start x sub start is greater than the n, then what we want to do is update our n value as well to a pointer. However, this is not an overlapping moment, so therefore we could shoot the arrow and increment output by 1. Alright, at the end of all this, we want to return our output. Let's erase this, give it a little run. Looks okay. Okay, accepted. Awesome. So, I mean, this is not really, I mean, they're both moderate, okay, in terms of time and space complexity. So, time complexity is big O of n log n plus a sorting algorithm as well. So big O of n log n, including the sort method at the beginning. Space complexity is big O of constant space because we store inside one variable called output. So there you go. That's pretty much it. Have you guys a nice day. Take care.